Hello everyone. Myself Chaitanya JS, currently pursuing my second year BE in the Department of CSE CY in Sri Venkateswara College of Engineering, Vidyanagar, Bangalore. Today I am here to explain about Karnaugh Map, which is also known as K-mapping. Introduction to Karnaugh Maps. Karnaugh Maps are diagrammatic tools used to simplify a Boolean algebraic expression. They provide a visual method of minimizing logical functions without extensive calculations. Developed by Maurice Karnaugh in 1973, they are widely used in digital circuit designs. Structure of Karnaugh map. A Karnaugh map is organized in a grid format that represents all possible combinations of the input variables. Each cell in a grid corresponds to a minterm for a Boolean function. The arrangement of a cells follows gray code to ensure that only one variable changes between the adjacent cells. Variable representation. The number of variables determines the size of Karnaugh map. For example, two variables create 2 into 2 map. For three variables, it expands to a 2 into 4 layout, while four variables create a 4 into 4 grid. Each variable is represented by either 0 or 1, indicating its states in the minterm. The visual representation is as shown in the figure. Filling the Karnaugh map. To fill the map, list the minterms of a Boolean function and place a 1 in a corresponding cells. Cells do not correspond to the minterms are filled with zeros. This creates a visual representation of a function that can be analyzed for simplification. Grouping ones. The next step involves grouping adjacent ones into a rectangles which can include 1, 2, 4 or 8 cells. Group must be formed in a powers of 2 and can wrap around the edges of map. Overlapping groups is allowed and can help in achieving a simpler expressions. Simplification process. Each group represents a simplified product term in a final Boolean expression. Variables that remain a constant within a group and are retained it in a simplified term. The process reduces a complexity of a original function, making it easier to implement in circuits. Don't care condition. Don't care condition can included in the Karnaugh map to provide additional flexibility in a simplification. These conditions are represented by an X and can be treated as either 0 or 1. Utilizing don't care conditions can lead further reduction of logical expression. Applications of Karnaugh maps. Karnaugh maps are extensively used in digital electronics for designing and optimizing combinational circuits. They are also utilized in fields like computer science for simplifying logical expression in a software. Additionally, they serve as educational tools for teaching Boolean algebra concepts. Limitations of Karnaugh maps. While Karnaugh maps are effective for small numbers of variables, they become difficult for a larger sets. Typically, they are practical for up to 4 to 5 variables. Beyond that, other methods like Quine-Mikulski algorithm are preferable. Their visual nature can also lead to errors if not carefully constructed and analyzed. Conclusion. Karnaugh mapping provides an intensive approach to simplifying Boolean expression effectively. Their visual format allows quick identification of common terms and simplification opportunities. Mastering Karnaugh maps can significant to enhance one's skills in digital logic designs and analysis.